Hi everyone, welcome to this new lecture of hydraulic machine. In this lecture, we'll solve a problem on double acting reciprocating pump. So in our last lecture, we have seen the problem on single acting reciprocating pump, and here we'll solve the problem on double acting reciprocating pump. So I have taken the question: a double acting reciprocating pump running at 40 rpm is discharging 40 rpm it is running, discharging 1 meter cube per minute. The pump has a stroke of 400 millimeter. The diameter of the piston is 200 millimeter. The delivery and suction head are both 20 meter and 5 meter respectively. Find the slip of the pump, power required to drive the pump. So two things we need to calculate. One is slip, another one is power required. So first of all, we'll write down the data given here. So from the question you can easily find out the data given. Then we'll go for the solution, that what we need to calculate. So the question is very simple, that we need to only solve, we need to calculate two things. One is slip, another one is power. So in the data given, if you see, we have the values are like its speed is given, that is speed of the pump is given, speed of pump is given, that is nothing but denoted by N, capital N, and capital N is given, this is 40 rpm. And the second is given discharging. So discharge is given, so you can write discharge. So discharge is nothing but denoted by Q. So this discharge is nothing but, this is the actual discharge here. Okay, so actual discharge is nothing but we can write 1 meter cube per minute. So this is given in meter cube per minute. If you want to change it to second, we can just change it by 1 by 60. So this can be written meter cube per second. And if you divide it, 10 divided by like 100 divided by 60, if you do like 0.01666, some value will come. So that is meter cube per second. Okay. The next one is pump has a stroke length. So stroke length is given. So that is we know that L. The stroke length is nothing but, which is given L, and that is given 400 millimeter. So 400 millimeter we can convert it to meter, so 0.4 meter. Similarly, diameter of the piston is given. So diameter D is given 200 millimeter. So again this one also you can convert into meter, 0.2 meter. So one diameter given means we can calculate the area by the formula of pi by 4. This is D square. Okay, this will calculate. Now the next one is given delivery head and suction head. So delivery head is nothing but how much water need to, like the water need to be delivered from this pump to what distance. So delivery head HD given, that is 20 meter, and the value of HS suction head, that is given 5 meter. Okay, so these are the data that are given in our question, and what you need to calculate. So calculation part is only two things are there. One is slip, another one is power required. So the calculate part we can write, the first one is slip. So slip, we know the formula is very simple, that this is the difference between the theoretical discharge minus actual discharge. This is the slip formula. And the second one is what? Power required. The power required to drive the pump. So P equal to, though this is the double acting reciprocating pump, 2 will be multiplied here. So 2 rho G ALN into HS plus SD. This is the formula while we have discussed about the double acting reciprocating pump. We got this formula at that time, divided by 60,000 to make it into kilowatt. Okay, so this is the formula for this. Now here let's first solve this one, pi by 4 into 0.2 square. So it will be mostly, let me write like 3.14 is the value, this one. This is 0.04 and divided by 4. So this will be 4 will be cancelled. So 0.01. If I multiply with this one, then I'll get 0.03146 meter square. Directly you can write the same value. Yeah, now okay, before going to this slip value, we need to calculate the theoretical discharge. So theoretical discharge, to calculate this theoretical discharge, let me write here. Theoretical discharge formula is 2 ALN by 60. For single acting reciprocating pump, we have the formula ALN by 60. Though it is double acting reciprocating pump, we need to multiply 2 there. Okay, so 2 into, this is 0.03146 into length. Stroke length is how much? That is 0.4. Speed is 40 and divided by, this is 60 is there. Now we need to solve this. Then we'll find out the theoretical discharge. Now let me see whether this value is correct or not. 0.2 square into pi and divided by, this is 4. Okay, 0.0314. okay, we got the same thing. Now this multiply into 2 into 0.4 into 40 divided by 60, 0.0167. so we got the value here, 0.01675. so this is meter cube per second. This is our theoretical discharge here. Once you find out the theoretical value, the remaining are very, very simple. So theoretical discharge here you can write, this is 0.01675 minus actual discharge is how much? Okay, actual discharge is this one. This is 0.01666. so I just minus this value, minus 0.01666, like that we can do. So we'll get the value of like very, very small. Okay, 10 to the power minus 5 if I take, then we'll get a value. I can write here 0.00009. so I'll write 0.00009. some value will be there. So this much slip is there. Okay, this is our first answer. Okay, and the second answer we can write here, just to multiply 2 into rho value how much? That is 1000, and G is 9.81. area we have already calculated, that is 0.031416 into L is 0.4, N is 40, HS plus HD 20 plus 5 and divided by, this is 60,000. so in the 60,000, let me cancel these 3 zeros, only 60 will be there. So anyway, we need to find out how much kilowatt is there. Even if you solve with one more zero also, we can cancel it. Okay, and here if you cancel this one, we'll get 3. Okay, this will be also very simple. Okay, by this we can calculate how much. So make it 0. Now I can calculate 9.81 multiply 0.0311416 and multiply 0.4, again multiply 4, again multiply 25. This divided by, here it is 3 is there, 4.109. so this 4.109, this much power required, this much kilowatt. Okay, because here if you see the 60,000 value is there, that is converted into kilowatt. If only 60 will be there, that will be in the point of watt. Okay, so this much power is required to drive the pump. Okay, this is our answer. Okay, this is our first answer and this is our second answer. So I hope you understand how to solve this problem. Very simple. Only these two formula we need to remember. Even like apart from that, some other formulas are there. Okay, so power required to drive, work done, or discharge, these things we can remember. Okay, I hope you understand this problem. Still, if you are having any doubt and query regarding this, you can give a comment on the comment box. Thank you all.